Hey everyone, and welcome to The Explainer. Today, we're going to attempt a massive cosmic zoom right into the physics of our star. I mean, we see the sun literally every single day, yet its physical reality is completely mind-blowing. Our human brains genuinely struggle to process massive cosmic scales, so today we're going to break it down using some incredible data to see just how big the sun really is. Let's kick things off with scale and mass, and frankly, get ready to have your perception of size completely shattered. To truly wrap our heads around solar physics, let's use a down-to-earth analogy. Imagine the sun is shrunk all the way down to the size of a standard basketball sitting right in front of you. Where's the Earth in this scenario, and how big is it? Well, the Earth would be a tiny little sesame seed, and it wouldn't be sitting right next to the basketball either. That sesame seed would be located roughly 26 meters or about 85 feet away from you. Think about that for a second. A single sesame seed sitting almost a whole basketball court's length away. That vivid, vast, empty space in between is really just the beginning of understanding our solar system's scale. And the scale gets even more staggering when we start looking at volume. 1.3 million. If you were to hollow out the sun and treat it like some giant cosmic jar, you would need to toss 1.3 million Earths into it just to completely fill it up. 1.3 million of our entire world, with all its oceans, mountains, continents just swallowed up to match the physical space the sun takes up. This point is really driven home by the hard data from NASA. The sun has a diameter of 865,000 miles. That's about 1.4 million kilometers across. But look, size isn't just about width, right? It's about sheer mass. The mass of the sun equals more than 330,000 Earths combined. This single object contains practically all the mass in our entire solar system. Everything else, all the planets, the moons, the asteroids, they are basically just rounding errors compared to the heavyweight champion sitting right at the center. Moving on to something a bit weird, the corona mystery and some truly extreme temperatures. Okay, now that we've got our heads wrapped around the physical size, let's plunge directly into a highly counterintuitive scientific mystery about the sun's heat. Let's track the temperature as we move from the inside out. In the core, where nuclear fusion is actively happening, the temperature is an unimaginable 27 million degrees Fahrenheit, 15 million degrees Celsius. Then, as we move outward to the surface of the sun, the temperature drops massively, down to a relatively cool 10,000 degrees Fahrenheit. That makes logical sense, right? You move away from the furnace and it gets cooler. But once you leave the surface and enter the sun's outer atmosphere, called the corona, the temperature suddenly and violently spikes back up to 3.5 million degrees Fahrenheit. Which leads us directly to this massive question. Why on earth does it get hotter further away from the surface? I mean, if you walk away from a campfire, you get colder, not hotter. Yet the sun's outer atmosphere is hundreds of times hotter than its actual surface. I really want you to think about that because, fascinatingly, this remains one of the single biggest unsolved puzzles in solar physics today. Scientists have theories about magnetic waves injecting energy into the atmosphere, but the exact mechanics of this corona heating mystery, they're still actively being studied. All right, next up, a fluid spinning giant. Let's talk non-solid mechanics. You know, as Earthlings, we stand on solid rock, so we just naturally assume massive celestial objects must operate like big solid rocks. But because the sun is a ball of blazing hot gas and plasma, it doesn't rotate as one solid sphere like the Earth does. It experiences what we call differential rotation. At its equator, the sun completes one full rotation every 25 days. But up near its poles, it moves much slower, taking about 36 days to complete a spin. The equator literally outpaces the poles. This dynamic difference in speed is absolute proof that the sun is acting as a fluid. It's constantly churning, twisting, and dragging its magnetic fields along with it, creating incredibly complex internal mechanics. Which brings us to space weather, flares and mass ejections. That twisting, fluid motion, it doesn't just stay neatly inside the sun. All that twisting plasma actually generates explosive events called space weather. You're going to hear the term coronal mass ejections a lot, or CMEs. These are massive, highly energetic bursts of solar wind and magnetic fields that rise above the solar corona and are violently released into deep space. Imagine billions of tons of solar particles exploding outward at millions of miles per hour. These are fast-paced, explosive storms of sheer energy, and they are happening right now in our solar system. And the crazy part is, we're actively watching them. NASA's Solar Dynamics Observatory constantly monitors these intense solar flares and mass ejections. So this isn't just history or theoretical physics. This is active, real-time observation. Scientists keep a very close eye on these magnificent and, let's be honest, dangerous explosive events, because when a CME is directed toward Earth, it can interact with our own magnetic field. That causes beautiful auroras, sure, but it can also potentially disrupt our satellites and power grids. Let's zoom out for the final piece, a cosmic lifespan and the big picture. So, we've spent a lot of time looking at fiery, violent physics, but let's zoom all the way out and place our sun in the vast context of deep time. Our sun formed roughly 4.6 billion years ago from a massive cloud of gas and dust. But it doesn't just sit still in the dark. It's located in a structure called the Orion Spur of the Milky Way galaxy. And right now, as you're listening to this, the sun is moving at tremendous speeds, dragging our Earth and the entire solar system along with it, completing one full orbit around the galactic center of the Milky Way every 230 million years. You are currently on a multi-million-year galactic road trip, all powered by the gravity of our star. It's really worth pausing just to let this profound fact sink in. Every atom in your body was forged in a star like this. When stars eventually die, they blow their newly created elements out into the cosmos. The carbon in your cells, the oxygen in your lungs, the iron in your blood, none of it was created on Earth. It was all cooked in the fiery core of ancient stars. You are, quite literally, made of star stuff. So, knowing this massive cosmic scale, the 1.3 million Earths that could fit inside the sun, the fluid magnetic plasma, the millions of degrees of heat, and the 4.6 billion years of history, how does it change how you view your own connection to the universe? You aren't just sitting in the universe observing it. You are biologically and chemically connected to the very stars themselves. I really hope this explainer sparked a deeper curiosity about astrophysics for you today. Keep questioning, keep looking up, and thank you so much for joining me.